Hello to all of you. So in previous lecture we discussed about different components of diversion headwork. Clear? So till the previous lecture we discussed undersluice. Clear? So in this lecture we will discuss about canal head regulator. So we will start canal head regulator. So what is the location of canal head regulator? So canal head regulator is constructed at the head of canal, means upstream side of the main canal, or we can say that off taking canal. Clear? So that CHR, that means canal head regulator, which consists piers, means piers foundation, and which is operated by GAT. Clear? So in this CHR, this is operated by different types of gate. So what is the span length? So the span length is approx 6 to 8 meter, which are commonly used. So what are the function or what are the purpose of CHR? So this is a diagram of CHR. Clear? So this is a gate, or we can say the breast wall, that called cistern. That is a undersluice, and silt excluder, which is below the ground level of CHR. Clear? So what are the functions? So first function is to supply a water to canal, or we can say that it can regulate or control the water which are entering to the canal. Then second one, to control soil entry, or sorry, to control silt entry. So we can provide silt ejector or silt excluder. Then third one, it excludes high floods from entering to canal. Otherwise, we can say that when in monsoon season, the input of water is very high. So the maximum amount of water which goes into the canal, so the canal will be damaged. That's why CHR provided to maximum amount or maximum capacity of amount of water which are entering into the canal is prevented by CHR. Clear? So this is a CHR, which normally 6 to 8 meter span length, pier constructions and gates are provided. So there are some design consideration of CHR. So first one, waterway. Waterway means the path of water. Clear? Which is sufficient to pass, which is required discharge into the canal. Like the waterway of CHR, which is perimeter 2 meter. Clear? But the canal require 3 meter. So CHR at that time is failed. Clear? So the length, or we can say that perimeter, or we can say that waterway, which is same for CHR as well as canal. So how can you find the discharge? So that formula is equals to Q equals to 1.7 into L minus K NH H raised to 3 by 2. So what is the H? What is the K? What is the N? So K, that coefficient of contractions, N means numbers of contraction, H means head, L means length of span. Clear? Then second one, for a head regulator with a broad case and sloping glacis which at the downstream side, the following discharge equation is applicable, which is Q equals to, which I discussed, that is the equation. Q equals to 1.7 L minus K into N into H raised to 3 by 2. Clear? Then third one, the regulators are aligned 90 degree to the weir. Done. But we can provide 110 degree for providing smooth entry. Clear? So first condition is that it is a perpendicular, or we can say that we also require smooth entry. So the angle will be changed, which is 110 degree. Then fourth one. Clear? So how can you prevent silt entry the canal? So first of all, you can do, the head regulator should be higher, means HR level should be higher than that undersluice level. But how many? 1.2 meter. Clear? When silt excluder is not provided. Then if there are silt excluder is provided, so the distance will change or the level will change, which is 1.8 meter. Clear? Please remember that this is the design considerations of CHR. Then fifth one, from the crest of regulator, a glacis is provided. Glacis means sloping is provided for the hydraulic jump. Clear? Under different discharge conditions. So obviously we provided slope at the downstream side. So what will happen? Obviously hydraulic jump occur. You know that what is the meaning of hydraulic jump? Clear? Beyond the glaciers means beyond the sloping of horizontal floor, the length is required, which is 5 into maximum height of jump. So what is the height? Means d2 minus d1, that called the height of hydraulic jump. So what is the distance or what is the length, which is 5 into d2 minus d1, that called the horizontal floor length. Then concrete cutoff at the end of impervious floor should always be provided. Keep the exit gradient well within the limits. Means cutoff or pile which is provided at the downstream side as well as upstream side to keep in limit of the exit gradient. Exit gradient means the slope provided at the exit point, otherwise at the downstream point of weir, that call or weir, or we can say the dam, that called exit gradient. Clear? The next one, piers separating the various parts of the regulator should be extended beyond the glaciers. That may be provide support to upward bending horizontal flow like this. In this diagram, you can easily show that the pier is extended to the downstream side. Clear? So we can easily control the bending moment of that particular weir. Done? So these are the design considerations of CHR. The next, silt excluder. So that silt excluder is provided, sorry, silt excluder is provided head of the main canal. Clear? Otherwise, inner the structure of weir. Done? So what is the purpose of silt excluder? So the purpose of silt excluder means to prevent entry in the silt into the main canal. Clear? That called silt excluder. So there are different types of tunnel are provided. Clear? So near about the divide wall, the tunnel length which is small. After you going to the CHR, towards to CHR, so the tunnel length will increase. Clear? So in this process, when waters flow through the tunnel, clear, then the specific gravity of silt is very high as compared to water. So the silt which will settle down between the tunnel and the rim and the upper layer of water which is clear. So that upper layer of water go to CHR. Clear? So this is the process you can prevent entry of silt into the main canal. The next one, guide banks. You know that guide banks? These are the guide banks, number 8 or marginal bund. So guide banks which are provided on the both side of your diversion headwork. Clear? In alluvial soil. So what is the purpose? As per the name, which is guide banks which guide the flow of that water, or we can say that river. Clear? So this is a guide bank or marginal bund. And also it controls the velocity of flow near the structure and near the site, and that protect barrage from the effect of scouring and erosion. So by the guide bank you can prevent the scouring and erosion, and you also control the velocity of flow. And it also provides a straight path, otherwise we can say that it provides a straight waterway towards the barrage or pier. The next one, marginal bund. So marginal bunds are earthen embankment, means it is made from the earthen material. It also prevent the flood water or storage water from the entering surrounding area, which may be submerged or may be waterlogged due to the flood. Clear? It also protects the town and village from the destruction during heavy flood, as I said that. It also protects valuable agricultural land. So this is the purpose of marginal bund. The next one, silt ejector, or we can say that silt extractor. So this is the basic difference between silt excluder or silt ejector. So main difference is that silt ejector is provided at the downstream side of off-taking canal. Clear? Otherwise downstream of the CHR. When some silt are already entering into the main canal, so that silt can be removed by the silt ejector. Clear? So this is a basic difference of silt ejector and silt excluder. Purpose is same, to remove the silt entry or remove the silt. But silt excluder is provided at the upstream side of CHR, but silt ejector provided at the downstream side of CHR. So by the figure you can easily show that easily so that this is a one type of, just a minute, I will show you. Clear? So this is a one type of small tunnel, clear, which is below the ground level. So when flow is entering into the canal, so that silt obviously at the downward side, so silt easily entered into this type of canal and can easily removed by this tunnel. Clear? So this is a section diagram. So this is the process in silt ejector, or we can say that silt extractor. Please remember the diagram. Diagram is very important. So the next one, causes of failure of wear on pervious foundation and their remedies. If impervious foundations are provided, so there are less chances of failure. So there are two types of failure. First one, subsurface flow, or second one, surface flow. So first one we can see that due to subsurface flow. So there are two, by piping or by undermining or by uplift pressure. So what are the uh, situation in by piping? So like water seeps under the base of weir and founded permeable soil. So that flow line emerge out at the downstream side, and the impervious floor of the hydraulic gradient or the exit gradient may exceed certain limit of that critical to soil, like maximum limit 1. If the exit gradient above the 1, so that piping or undermining will be occur. Clear? So in these conditions, that soil particle lifted up at the end of the flow and washed away by percolating water. So this is the conditions which occurred in piping. Clear? So with the removal of the surface soil is further concentrations of flow into the resulting depression and soil is removed. So what are the remedies? So first one, you can provide impervious flow so that exit gradient will be decreased. Then second one, provide piles at downstream side as well as upstream side end of the impervious flow. Then second one, by uplift pressure. So in uplift pressure, the next one, by uplift pressure. So in these conditions, water percolating through the foundation and exert or produce uplift pressure. So if the weight of floor is sufficient to resist uplift pressure, the floor may fail by rupture. Clear? So in this condition, what is the remedies? So first one, you can provide or increase the impervious floor thickness. Then second one, the length. The length of impervious floor will be sufficient to resist uplift pressure. And third one, you provide also pile at the upstream side of impervious floor to reduce uplift pressure on downstream side. So these are the three remedies which are used to minimize this condition. The third or second one, failure due to surface flow. Again, there are two conditions: failure by suction due to standing wave, or we can say that hydraulic jump. The second one, failures occur on upstream and downstream side of river or weir. So first one, due to standing wave or hydraulic jump. So standing wave formed obviously at the downstream side of weir cause suction, which also act as in the direction of uplift cross. So if the floor thickness is insufficient, it may be failed. Standing wave may be always occurred in the downstream side of weir. Due to this, uplift pressure are increased. So if we already studied that if the weight is insufficient to resist uplift pressure, though, then that particular weir will be failed. So what are the remedies? Again, same remedies. First one, providing additional thickness of the impervious floor, means increasing a weight of that floor. Then second one, constructing floor as a monolithic concrete mass, means that impervious floor which is constructed by monolithic structure, means homogeneous. Then second one, due to scouring upstream side as well as downstream side. So obviously both sides of impervious floor river may be scoured to considerable depth during floods, means the intensity during the floods which is very high due to the scouring will be occurred. So that scour hole means small holes are occur at the face of upstream and downstream side, and this progress towards the structure means uh, you know that in hydrology engineering you studied in dam engineering. In that module, there are small holes are occurred due to force as well as some insect. So due to that, the holes are towards to the thoroughly of structure. Due to that, particular weir or dam will be failed. So same as that, but in this condition, we already consider the scouring. So what are the remedies? So first one, deep piles provided as well as upstream and downstream side. Clear. Then after providing launching apron of suitable land and thickness of upstream and downstream and of impervious floor. So what is the launching apron? Launching apron means it is a one type of a structure which used for dissipations of energy. Clear? There are some factors which are governing of design of weir. So what are the factors? First one, lattice factor, afflux, design discharge, water weight, discharge intensity, concentration factor. So first one, what is the lattice factor? Silt factor. Clear? It is derived by lattice, which we'll discuss in 7th chapter open channel flow. So what is the formula? So this is the formula of silt factor, which is 1.76 under root mr. Mr means average mean particle size. Afflux. Afflux means rise or increase in water level on the upstream side of the structure after the construction of weir. That called afflux. Means you construct a weir in Sabarmati river. Clear? So the depth of Sabarmati river, for example, 15 meter. But after the construction of weir, the depth will be increased by 20 meter. So that increasing depth, that called afflux. Then design discharge. Clear? So as per the irrigation department, they suggest different criteria for fixing design flood discharge. So that first is CWC, Khosla committee, and our IS code. Clear? So this is design flood discharge. Then waterway. Waterway, as I said that this is a path of water. Clear? The length of waterway should be adequate to pass design floods safely. If the length of waterway should not be sufficient, so the property will be damaged. Clear? And the length of waterway and the afflux, which are interrelated. Like afflux is increased, then waterway will be decreased, and vice versa. So how can you find the parameter? So this is the formula already we discussed in 7th chapter, that called open channel flow, that called Lacey's design. Then by the Lacey's, that he person is defined a formula for parameter from the discharge. So formula is P equals to 4.75 under root Q. Then design discharge intensity. So the definition is discharge per unit length, means Q divided by L, that called discharge intensity. Done. So when the discharge intensity is higher, so the length of waterway is shorter. Clear? And vice versa. Please remember that point. When the design discharge intensity is higher, so length will be, the length of waterway will be shorter. Then concentration factor. So the what is the concentration factor? Is equals to increase in design discharge intensity divided by average discharge intensity multiply 100. So most of the time concentration factor is near about 20%. Clear? But when the question is asked concentration factor which is throughout the same, no. So where the concentration factor which change length to length. The next theory is Blitzkrieg theory. So what is the Blitzkrieg theory? Please remember that is a very important topic, Blitzkrieg theory. Clear? That topic will be discussed in next session. Clear? Thank you for attention.